So welcome, this is CAIE 0607 paper 6 of 2020 version 62. So we shall try to solve the questions. The first question is from investigation, question 1 to 6, dotty polygons. So we shall read very carefully. You are advised to spend no more than 50 minutes. This investigation is about the number of dots in the shape of a regular polygons. P is the number of sides. Remember, P is the number of sides. N is the number of dots on one side. There are same number of dots on each side. So that is the same number of dots on each side. This is a dotted triangle. You can see that there are 4 dots on this one side, 4 dots on this side, and 4 dots on this side. So this is a dotted triangle. P is equal to 3 because number of sides in a triangle, we have 3 sides. So therefore P equal to 3. And how many dots are on each side? 4 dots are on each side. Look at the number of the dots in each row of the triangle. Complete the sum. So in the first row there is 1, in the second row there is 2, in the third row it is 3, and in the fourth row it is 4. So totally there should be going to be 10. Show that n square upon 2 plus n upon 2 gives the correct number of dots when n is equal to 10. So we can see that what is the pattern over here? There are 4 rows. So I have multiplied up to 4 dots on the n. N is nothing but what? Number of dots on the each side. So when n is equal to 10, there will be a triangle. There will be a triangle with 10 dots on the each side. So I can take it out 10 dots. 1, 2, 3, 4, 5. So I draw it much more spaciously. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 dots on each side. So I'm starting with 1. So when I'm starting with 1, so it should be 1 plus total number of dots should be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. Add them all, it is 55. When I use this formula also, I should be getting 55. So use n is equal to 10, 10 square upon 2 plus 10 upon 2, 100 upon 2 plus 5, which is nothing but what? 50 plus 5, which is 55. So the formula is correct. So number of dots formula is n square upon 2 plus n upon 2. That is for a triangle. Remember, that is for triangle. The number of dots is n square upon 2 plus n upon 2. Now the diagram shows 4 dotty triangles. These are dotty triangles. The number of dots added each time is d. The number of dots added each time is d. So when n is equal to 1, there is 1 dot. When n is equal to 2, I'm adding 2 more dots. When n is equal to 3, I'm adding 3 more dots. When n is equal to 4, I'm adding 4 more dots. So for the dotted triangles, n is equal to d equal to n. So what was n again? Number of dots on each side. And dotted triangles, what do I mean by dotted triangles? Number of dots added is equal to each time is d. Now this diagram shows first 4 dotty squares. N is equal to 1, d equal to 1. N is equal to 2. There are two dots on each side. N equal to 2. But d equal to nothing but what? I have to add 3 more. So what is the pattern you can see? 2 has been added. 2 has been added. You can see the pattern. 2 has been added. Find an expression in terms of n, the number of dots in the nth dot square. So we have to see the pattern for the number of the dots. So what is the pattern over here? So in the second diagram, the number of dots is 4. In the third diagram, the number of dots is 9. In the fourth diagram, the number of dots is 16. So you can see that it is square. 2 square is 4, 3 square is 9, and 4 square is 16. So in the nth diagram, the number of dots will be equal to n square. That is the pattern. Find for dotty squares, find the formula for d in terms of n. So we can see that when n is equal to 1, d equal to 1. When n equal to 2, d equal to 3. Then when n equal to 3, d equal to 5. So what is the series over here? 1, 3, 5, 7. It should be 9 and so on. I want the nth term. So we know that if at all the nth term is there, then what is the difference? The difference is 2. 2, 2, 2. So it should be 2 times n. If there is a constant difference, it should be 2 times n, 2n. So when n is equal to 1, it should be 2 times 1. 2 times 1, what does it becomes? 2. But is that 2? It's not 2, it is 1. So it is 1 less than. So it can be written as 2n minus 1. We can cross check whether it is 2n minus 1 or not. So when n is equal to 2, so I write it out neatly over here once again. So the pattern was 1, 3, 5, 7, 9 and so on. The common difference is nothing but how much? 2. So my nth term should be in the form of 2n plus some number plus some number plus or minus some number a, so or b. So how should I find it out at b value? So when n is equal to 1, I got it should be 1. So 2 times 1, it should be made as 1. So when is it possible to make it 1? If I subtract 1. Now for n is equal to 2, 2 times 2 is 4, but I should be getting 3. So still, is it minus 1 is possible or not? Is it still valid? Yes. Then check for n is equal to 3. So 2 times 3 is 6, but I want for 5. So what should I be subtracting it out? Minus 1. So my answer should be 2n minus 1. A formula for d in terms of p. P is the number of sides and n. N is nothing but what? Number of dots on the sides. D is the number of dots. Dot. A formula for D in terms of P. So what is D? First of all, D is not the number of dots. It is the number of dots added. So a formula for D in terms of P. P is the number of sides and N is the number of dots on the sides. D is equal to P minus 2 times N minus P plus 3. For dotty pentagon, show that this formula is this one. So dotty pentagon. Pentagon means how many sides it should be having? 5 sides. So just plug in 5 over here. 5 minus 2 times n minus 5 plus 3. So this becomes 3n minus 2. That is has to be proved. This diagram shows first 3 dotty pentagons. So this is the first pentagon, second pentagon, and third pentagon. So for dotty pentagon, d equal to 1 and total number of dots is equal to 1 and d equal to 4. So I'm adding 4 more dots and total number of dots is 5. Next time I'm adding 7 more dots and total number of dots is going to be 12. Dotty pentagons grow along the gray lines. This diagram shows the formation of first 3 dotty pentagons. Complete the diagram for 4th and 5th. So I have to complete the diagram for 4th and 5th pentagon. We can see that for the second pentagon there are 2 dots on each line. Number of dots on each line is 2 dots. For the third pentagon there are 3 dots on each line. Again you can see that 3 dots on each line. So obviously for the fourth pentagon there will be 4 dots on each line. So I go for 4 dots. So 1, 2, 3, 4. 1, 2, 3. I space them around 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So on the fourth pentagon, there will be 4 dots on each side. And on the fifth pentagon, there should be 5 dots on each side. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So space them properly. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we can see that there are 5 dots on each pentagon. On each side, there are 5 dots. This table shows total number of dots in some dotty polygons. The question in use question 2 and 3 and any patterns you notice to help to find the complete the table. Triangle, there are 3 sides. Square, there are 4 sides. Pentagon, there are 5 sides. Hexagon, there are 6 sides. So we can see that we have to fill this table. For the third dotty triangle, it is 6 and 10. So dotty triangle, we have gone for dotty triangle. In the third dotted triangle, we can see that there are 6 dots. In the fourth dotted triangle, there are how many dots? 10 dots. And in the fifth dotted triangle, we know the formula, it is n square upon 2 plus n upon 2. So it will be 25 upon 2 plus 5 upon 2, 30 upon 2, which is nothing but what? 15. Now for square, the formula we have derived, if you remember, it was n square. So for fifth one, it should be 25. Now he says, see any pattern. We can see the pattern over here. The increase is 3, the increase is 3. So 12 becomes, another increase will be 3, 15. You can see the pattern over here. This increase is 6. Now the next increase also will be going to be 6, which is 22. The next increase also is going to be 6, which is 28. Now lastly, we can see that the increase is 10. So here the increase will be 10, so it is 35. Here the increase will be 10, which is 45. So this is going to be the pattern. You need to check the pattern and fill the table. Complete this expression in terms of n for the total number of dots in any dotty pentagon. In any dotty pentagon. So what is the formula for n? So for pentagon, 1, 5, 12, 22, 35. This is a values. So what is the difference in between these two? The difference is nothing but what? 4, and difference is 7, difference is 10, difference is 13. Now again further the difference is going to be 3, 3 and 3. So in the second stage it is going to be 3, 3, 3. Whenever it is in the second stage 3, 3, 3, 3, this is called as a quadratic sequence. So remember, this is called as a quadratic sequence. So in that case, it should be in the form of an square plus bn plus c. The nth term should be in the form of an square plus bn plus c. Now, how is that? So we shall do that one. We shall do some working over here. N is equal to 1, 2, and 3. If n is equal to 1, the first one will be a times 1 square plus b times 1 plus c. A plus b plus c. Second term will be a times 2 square, which is 4a, 2 times b plus c. The third term will be a times 3 square, 9a plus 3 times b plus c. This will be the first term of the expression. Now second difference is when you find the difference between these two. When I subtract these two, the difference is going to be nothing but how much? I have to find the difference between these two. This is 3a plus b. And difference between these two will be nothing but what? 5a plus b. So that's the reason the difference is not same. Now when I go for the next one, the difference between these two is going to be 2a, which is going to be constant. So now we can see that the constant difference is 2a, and over here the constant difference is 3. So 2a is equal to 3. So a is equal to 3 upon 2. So 3 upon 2 n square. See, that is only has been there, 3 upon 2 n square. Now, next we can clearly see that carefully. The first difference is 3a plus b, and the first difference is nothing but what? 4. So 3a plus b is equal to 4. So 3 times a is 3 upon 2 plus b is equal to 4. So b is equal to 4 minus 9 upon 2, which is minus 1 upon 2. So minus 1 upon 2 n, minus 1 upon 2 n. I need to find the value of c. How can I find the value of c? We can see that the first term is a plus b plus c. The first term is 1. So a plus b plus c should be equal to 1. A plus b plus c should be equal to 1. A is how much? 3 upon 2. B is negative 1 upon 2 plus c is equal to 1. So 1 plus c equal to 1. So c equal to 0. So this is going to be the expression. So remember, quadratic sequence. Whenever there is a difference in the second step, common difference in the first step is not same, the difference is there, common difference is there in the second step, we are going to use an square plus bn plus c. So if you are not understanding, go back, rewind this video and keep on checking this one slowly, and remember that this is a quadratic expression, quadratic sequence. So for that, what am I going to do it is, I'm just adding a page over here and making the notes. You can make a notes of this one, nth term of quadratic sequence. So it should be, second difference should be constant. What is the condition? Second difference is constant. Over here we can see that second difference was 3, 3, 3, 3. Second time when I find the difference is constant, then the answer will be in the form of an square plus bn plus c. So quickly I draw a table to make it easy to understand. I draw a table over there. Then I draw some columns. N is equal to 1 and n is equal to 1 and it is 2 and 3. N equal to 1, n equal to 2, n equal to 3, and what is the term and first difference and second difference. So n is equal to 1, it's going to be a plus b plus c. If I substitute n is equal to 2, I get 4a plus 2b plus c, and n is equal to 3, I'm going to get 9a plus 3b plus c. So the first difference is going to be, the first difference over here, these two together gives me 3a plus b. Over here, these two together gives me 5a plus b. Now finally, these two together gives me 2a. So what is that? 2a is going to be the second difference. 3a plus b is going to be the second term minus first term. And a plus b plus c is going to be my first term. If you remember this one, any quadratic sequence, whenever there is a second difference is constant, we can use that. Coming to the question number 5. Use question for number 4 and any patterns to notice, you notice to help to complete the table. So for 4, it was n square. For 5, we have just for pentagon, we have done the formula 3n square upon 2 minus 1n upon 2. 3n square upon 2 minus n upon 2. Now what is the pattern? How should I find it out, the pattern? So let me write much more neatly. So this was n square. This was 3n square upon 2 minus n upon 2. To find the pattern, this is 1n square upon 2. So this is 2n square upon 2. You can see the pattern over there. What is the pattern? 1 became 2, 2 became 3. So this has to be 4n square upon 2. So this blank has to be 4n square upon 2. Find in terms of n and p an expression for the total number of dots in any dotty polygon. So now we have to find a formula for this one. So again, we have to find it out a pattern over here. How should I find a pattern over here? So we know that it is n square upon 2 plus something with n upon 2. Over here, what can I write is, it is 0 times n upon 2. And over here, it is 2n upon 2. So you can see that n upon 2 is common. N square upon 2 is common. I should be able to get the numbers. So between n and p. So when p is 3, see the pattern, when p is 3, n became 1. When p is 3, n became 1. So I'm talking about this part. For this part, p and n. When p is 3, n became 1. When p is 4, n became 2. When p is 5, n became 3. When p is 6, n became 4. You can see the difference is 2. So what can I do? I can erase this and write this as p minus 2. You can see that p minus 2 gives you n. So the p minus 2 gives you the number before n square upon 2. Now you have to see the pattern. So by doing more questions, you will be able to get the pattern. If at all you are doing this paper for the first time, you may be thinking that, oh, it is not very easy to get the pattern. But trust my word, upon doing so many questions, that is the reason I'm uploading all the questions papers long back. So the more the questions paper you do, the more the pattern visualization will be easier. Now I want to know the number over here. What is the pattern between p and n? You check it out. P and that number. It may not be n. P and that number. So P and that number. What is the pattern? If P is 3, that number is 1. If P is 4, that number is 0. P is 5, the number is minus 1. P is 6, the number is minus 2. So you can see the pattern. What is the pattern? It has to be 4 minus P, because 4 minus 3 is 1, 4 minus 4 is 0, 4 minus 5 is minus 1, 4 minus 6 is minus 2. So that number has to be 4 minus P. So what is the formula? P minus 2 times n square upon 2 plus 4 minus P times n upon 2. That formula has to be written in this blank. Question number 6. When P is equal to 50, the total number of dots in the n dotted polygon plus 865 is equal to the total number of dots in the n plus 1th polygon. So total number of dots in the nth polygon will be nothing but what just now we have done, P minus 2 n square upon 2 plus 4 minus P n upon 2 plus 865 should be equal to n plus 1. N plus 1th polygon. So it's same, P minus 2 times n plus 1th polygon whole square upon 2 on this side upon 2 plus 4 minus 50 upon 2 times n plus 1. So what does that becomes now? 50 minus 2 is 48, 24, 24 n square minus 44 minus 50 is minus 46, so minus 23 times n plus 865 is equal to, same again, 24 times n plus 1 whole square minus 23 times n plus 1. So 865 is equal to 24 times n plus 1 whole square minus 23 times n plus 1 minus 24 times n square plus 23 times n. Then I take 24 common, n plus 1 whole square minus n square minus 23 common or plus 23 common, or I can take minus 23 also common. So it becomes n plus 1 minus n should be equal to 865. So 865 is equal to 24. A plus b whole square is a square plus 2ab plus b square minus n square minus 23 times n plus 1 minus n. We can see that n and n gets cancels, n square gets cancels. 865 is equal to 48n plus 24 minus 23. So 865 is equal to 48n plus 1. So 865, 64 is equal to 48n. So n is equal to 18. So what is the value of n? N is 18. Coming to the modeling B, 7 to 10 questions. This task is about the distance a car travels as it stops. Show that the speed 130 kilometers per hour is approximately 36 meters per second. 130 kilometers into meters multiplied by 1000. 1 hour is 60 minutes. Each minute is 60 seconds. So 60 times 60. So this should be becoming 36.1 or approximately 36 meters per second. A car travels at 130 kilometers per hour. A model for the distance traveled d is given by d is equal to 36t. Write a similar model for traveling with 80 kilometers per hour. So 80 times 1000 divided by 60 times 60. So just to show you by calculator usage, I can do this by calculator. So it becomes, let me do the calculator part. So it becomes 80 times 1000 divided by 60 divided by 60. So should be giving you some 22.22. So 22.22. So D is equal to 22t. So take 22t. Now on the diagram, sketch both the models between t equal to 0 to 3. D equal to, what is the first one? D equal to 36t and D equal to 22t. Come to the graphing calculator, and what is this? 36x, a straight line, and 22x, a straight line, but it should be between 0 to 3. So 0 to 3. You can see that it is a straight line passing through 0, 0. The black one is having a smaller slope, and the purple one is having a bigger slope. So one line and another line. This is for 80. Now 22t, and this is for d equal to 36t. On your sketch, shade the region showing the distances traveled at speeds from 80 kilometers per hour to 130. So what should be the distance? Just between the graphs. Between 80 and 130, that is the distances traveled. When a driver looks at a mobile phone, they do not look at the road. On an average, they look at the mobile phone for 2 seconds. For the speeds between 80 and 130, Find the range of the distances that a car travels in these 2 seconds. What is the range of the distance a car travels in these 2 seconds? So what am I going to do it out? So d equal to 36t and d equal to 22t. So in these 2 seconds, 36 times 2, which is 72, because it was decimal, but we are taking into two significant figures. 22 times 2, which is 44. So the difference is nothing but what? It lies between 44 and 72. And don't forget to write the units meters that do cost the marks. A car continues to travel after the brakes are applied. Once the brakes are applied, the car will be continuing to travel. The distance traveled is the braking distance, and it is b is equal to v squared upon 20f. V is the speed of the car in meters per second. F is the measure of the grip of the tire on the road. When the road is dry, F is 0.7. Write and simplify the model for B when the road is dry. So B is equal to V square upon 20 times 0.7. So will become V square upon 14. When the road is icy, the value of F is 0.3. So B is equal to V square upon 20 times 0.3. So B is equal to V square upon 6. On the diagram, sketch between 0 to 20. V square upon 14, V square upon 6. I take away these two. So x square upon 14 and x square upon 6, and the limits for 0 to 20. X-axis is 0 to 20. You can see that it is a curves. Red one is x square upon 14 and the blue one is x square upon 6. X square upon 14 and x square upon 6. So this is B is equal to V square upon 14 and B is equal to V square upon 6. A car travels at 60 kilometers per hour. On a diagram in part C, sketch the vertical line 60 kilometers per hour. 60 kilometers is 1000 meters divided by 60 times 60. Do it out by calculator, it should be 16.7. So the speed is going to be 16.7. So draw a vertical line from 16.7. Maybe this is a vertical line because our graph should be much more perfect. So what am I going to do? Okay and okay. You can draw it out in this way. Now at 16.7, draw a straight line from 16.7. Go back over here, draw a vertical line, x equal to 16.7. What is he asking? Find how much greater the braking distance is when the road is icy than when the road is dry. So icy part and dry part. So what am I going to do it out? I am going to find it out. This point of intersections over here. Let me do it out over here. This point of intersection and this point of intersection and subtract both the answers. So for that, we can go back to the graphing calculator and check it out those values. So this value is 46.48 and 19.921. 46.482 and 19.921. 46.482 minus 19.921. So take the calculator. 46.482 minus 19.921, which is 26.561. So 26.561. 561. So three significant figures, 561. So I'm going to write 26.6. Coming to the last part, 10th part, Glenn is driving his car when the emergency happens. He usually takes 0.7 seconds to react. Because he is looking at his mobile phone, he takes extra 2 seconds. So totally 2 seconds for looking at the mobile phone, and his reaction time is 0.7 seconds. So totally he is wasting 2.7 seconds. So see, while driving the car, we should not be looking to the phone, and because though his reaction time is very less, 0.7, because of looking to the phone, he already used 2 seconds, wasted 2 seconds. So totally 2.7 seconds has been wasted. The weather is wet. The measure of the grip the tire has on the road is 0.5 this time. Glenn is traveling with a speed of x kilometers per hour. Show that it is approximately x meters per second, 0.28 x times 100,000 times 60 times 60. So this should be giving you 0.2777, so on x. So in two significant figures, 0.28x. Coming to the last part, the total stopping distance is the distance car travels from when the emergency happens to when the car stops. Use question 8 and 9 to find in terms of x a model for Glenn's stopping distance. So I have to find stopping distance. So what is the stopping distance? It should be of reaction time plus the mobile time plus the braking distance. This total should be the total stopping distance. So reaction time plus mobile time was 2.7 seconds. We have seen that 2.57 seconds, and it was traveling with a speed of 0.28x. We can see that they are traveling with a speed of 0.28x, and the time was 2.5 seconds. Now plus braking distance. What was the braking distance formula? If you remember, the braking distance formula has been given as v square upon 20f. So v square is 0.28x whole square upon 20 times f. F is 0.5 given. So simplify this. This should be giving you 0.756x plus 0.00784x squared. So my final answer is going to be 0.756x plus 0.00784x squared. That's going to be the answer. So that completes the paper. See you in the next paper. Bye.